Yeah, so if we look at the mathematical curriculum and we look at the fluency aim, fluency sort of has become, since the MTC, almost used interchangeably for meaning rapid recall. However, if we do look at the national curriculum, we can see that fluency is made up of three key strands. So we've got the efficiency strand. So we want that rapid recall, but we also want children to be able to choose efficient strategies that they might be able to use with very, very little effort to also get to the answer. So we want the efficiency, we want that rapid recall. We also want children to know and be able to explain how they know that they're accurate. So often I've heard children quite confidently sort of recall a fact, but when you say, how do you know, they have no idea, and actually what they've recalled is wrong. So that's another sort of reason why a strategy approach is so important. So we're empowering children with strategies and that deeper understanding so that they're able to explain how they know that they're accurate. And then we have the flexibility strand. So children being able to apply those facts in different maths contexts. So again, when I'm doing training, the number of teachers who say, yeah, they can recall them in order, starting from 1 times to 12
Yeah.
times. But if you ask them to use them in any way, they haven't got a clue. So it's that being able to apply what they know as well. So we've got the 3 strands of fluency, and all of those are underpinned by deep understanding, because how do children explain how they know they're accurate, or how are they able to apply them if they don't understand the maths, if they don't understand those facts? So that's kind of where I think we need to be thinking with fluency, of bringing together all of those 3 key strands and all of it underpinned with deep understanding.
And that makes, I'll completely agree, Kate, in terms of what fluency really means. I think it's often misconstrued as purely being about knowing your number facts, but actually I think true fluency is much greater than that. And if we
Yes,
use the analogy of languages, I could know how to read certain words in French and things, but that doesn't mean that I'm fluent in the language if I can't
yes,
use it to to converse and to make implications and all those sorts of things, the things that you need a deeper understanding of the
yes,
subject in order to be able to do,
yes,
and to be accurate as well, as you say.
yeah,
So I in my experience of working with teachers and in schools, I think times tables is one of those areas where a lot of time is potentially spent on it, but much of that time is not spent learning them in the way that we would teach other areas of maths. So, for instance, if I was teaching addition, I would be thinking about using concrete manipulatives. I would be thinking about, what pictorial representations am I going to use here? I would be at a very basic level. I would just be checking that children understand that we can put 2 groups together and find a sum, and making sure that the language is secure and all of those things. When it
yes,
comes to times tables, the most often the practice that I see is chanting them, or possibly putting a video on that plays a song with the times tables in,
yes,
and then the rest of the time is spent testing them or practicing them,
yes,
and not necessarily intelligent practice either. It's quite random often, although you might focus on one particular times table, I suppose. But in terms of actually teaching them, I think that's a skill that is, um, not as prevalent as it might be, let's say. So I'm really interested, Kate, and I know this is an area of your expertise. How did children learn multiplication facts? And what, if we're starting with counting in groups, for instance, to learn what multiplication is, or
yes.
repeated addition,